The cockpit is vibrating. You're 20,000 feet above the Pacific, scanning the endless blue. And then you see it. A speck. A Japanese Zero. You have the advantage. You're higher, you're faster. This is the moment you've trained for. You push the nose of your P-38 Lightning down to dive, and the engines sputter. A cough. A violent shudder. Then, silence. The propellers windmill uselessly. You are no longer a hunter. You are a 40-ton glider, a sitting duck. This was the nightmare facing American pilots in the Pacific. America's most advanced, most expensive, and most futuristic fighter plane was a death trap. It wasn't supposed to be this way. The Lockheed P-38 Lightning was hailed as an engineering marvel, a bold leap into the future of aerial warfare. On the drawing boards, it was a revolution, a machine built specifically to dominate the skies. It broke from the traditional single-engine fighter design by mounting two powerful Allison V1000 710 engines. This configuration gave it massive redundancy and sheer thrust unmatched by single-engine fighters of the era. The radical twin-boom tail assembly made it one of the most recognizable, distinctive shapes in the air, a profile that earned it the nickname the fork-tailed devil from its German foes. Its firepower was unprecedented. It didn't rely on wing-mounted guns, which had issues with convergence. Instead, it carried its entire arsenal, 4 heavy-caliber machine guns and a 20mm cannon, all clustered tightly and precisely in the nosepod. This centralized firepower meant its shots did not have to converge at a single distance. Every projectile flew straight, making it a devastating precision weapon at virtually any range. It was fast, boasting speeds approaching 400 miles per hour. It could fly higher than nearly any competitor thanks to its advanced turbo superchargers. The P-38 was designed to be the ultimate high-altitude interceptor, a predator meant to dominate and outclass anything the enemy could field. It was supposed to be invincible. But in the critical opening years of the war in the Pacific, this magnificent machine was facing an enemy that played by entirely different rules, an enemy it was fundamentally unprepared to fight. The nemesis was the Mitsubishi A6M0. The Zero was a master of the dogfight. Its design philosophy was entirely different from the American doctrine of armor and power. It was incredibly light, sacrificing pilot protection and fuel tanks for maximum agility. It possessed an unparalleled ability to turn tightly and quickly at low speeds and low altitudes, making it the most dangerous dance partner in the sky. It could outclimb, outturn, and outmaneuver virtually every Allied plane sent against it. It was flown by combat-hardened veterans who had dominated the skies over China for years. The heavy, powerful P-38 pilots, trained to engage in high-speed passes, were constantly tempted to engage the enemy in a turning battle. When they did, they were often outclassed. The P-38, with its heavier load and dual engines, couldn't follow the Zero's tight arcs. It would stall or lose excessive speed, leaving it vulnerable to the Zero's deadly cannons. The P-38 was being torn to shreds by a plane that was simpler, slower, and technologically inferior, but tactically superior in the turning game. The American superfighter had met its perfect counter. The pilots were not just frustrated, they were furious. They were dying in a plane that was supposed to be fundamentally superior. The problem wasn't the airframe's strength or its speed. It was the engine's utter unreliability when it mattered most. The P-38's complex turbo superchargers were a technological marvel designed to let the powerful Allison engines breathe perfectly at extreme altitudes. But they were only designed for the cold, dry air of the European stratosphere. In the blistering heat, corrosive humidity, and salt-filled air of the South Pacific, the system was a disaster. The engines constantly fouled, they overheated, The intricate fuel-air mixture system was being confused, dumping too much fuel into the cylinders, fouling the spark plugs, and choking the power. Right when pilots needed to commit to a dive or a climb, the engines would sputter, cough, and die. The plane was incapable of reaching its advertised top speed or sustaining its high altitude. Advantage: America's dream fighter had a deadly, secret flaw, and that flaw was crippling its ability to fight. The disaster was obvious to everyone in the combat theater, but the high command refused to admit defeat. The official orders that came down were terrifying and disheartening to the pilots. They were explicitly forbidden from dogfighting the Zero. The P-38's advantage was supposed to be its speed and its ability to climb. The new doctrine stated they could only use boom and zoom tactics, dive on the enemy, fire a burst, and immediately use the plane's powerful dive speed to escape. Under no circumstances were they to engage in a turning fight. But even this limited tactic was useless. If the engine mixture failed on the dive or the climb out, the plane was defenseless. The Zero pilots quickly learned the P-38's fatal unreliability. Morale plunged. America's most advanced fighter was a sitting duck. Pilots bitterly referred to the powerful twin-engine marvel as the Widowmaker. The plane was costing lives, and no one, not the generals, not the engineers, had a solution. The engineers back at Lockheed in California were receiving the desperate combat reports. They were completely stumped. They looked at the data: engine failures, carburetor issues, and poor high-altitude performance, but they couldn't replicate the disaster. Back in the dry, predictable air of the United States, the planes worked perfectly. They dismissed the combat reports as pilot error. They blamed the quality of the fuel being used on distant islands. They blamed the excessive humidity and the corrosive salt air, suggesting the environment was simply too harsh for their complex machine. They offered no real solution, only excuses. The engineers, highly educated and confident in their designs, refused to believe their precision-built marvel was fundamentally flawed. The lives of the pilots were being lost while the experts argued over climate and fuel purity. The lack of answers from the engineers didn't stop the flow of bad ideas from the high command. New official fixes were constantly being issued. Massive amounts of spare parts were shipped across the ocean, often taking months to arrive. New technical manuals were printed with complicated, detailed instructions for managing the engines and coaxing the turbo superchargers. Pilots were told to try complex maneuvers with the controls. They were forced to babysit the engines constantly, making minute adjustments in a desperate attempt to keep the power running. Nothing worked. The P-38 seconds were still flying with one hand tied behind their back, constantly fighting their own aircraft instead of the enemy. The planes were so unreliable that when a pilot took off, he wasn't sure if he'd return due to the Japanese Zero or the failed American engineering. The failure of the P-38 was costing more than just planes. It was costing the lives of some of America's best pilots. Even the legendary aces, the most gifted flyers, were being crippled by this engineering flaw. Consider Richard Dick Bong. He was a phenomenal talent, a natural hunter in the skies. But even Bong would land his plane, fuming, after a close call where his engine had sputtered out just as he tried to escape a Zero. He knew the plane should be a killer, but its unreliability made every flight a game of Russian roulette. Bong and the other frustrated pilots didn't complain to the distant engineers in California. They complained to the only people they trusted, their ground crew. This is where our hero emerges. He wasn't a college-educated design guru. He was just a mechanic, known around the airfield simply as Gene "Shorty" Axtell. He was the man who lived and breathed the P-38's complex engines, the grease monkey, who saw the problem not through theoretical charts, but through greasy wires and fouled spark plugs. And unlike the engineers, Shorty Axtell was actually listening. The mechanic, Shorty Axtell, wasn't focused on high-level aerodynamic theory. He was looking at the actual hardware, the carburetor, and the engine controls. He worked late into the night, studying the complex web of rods and wires that automatically controlled the fuel-air mixture. He saw the problem was entirely mechanical. The P-38's fuel system had an automatic mixture control designed to adjust the fuel precisely based on altitude and air density. This was genius in the factory, but terrible in the field. In the Pacific's humid, salty conditions, that complex automatic linkage was constantly being tricked. It thought the air was thicker than it was, causing it to flood the engines with too much fuel. That excess fuel quickly fouled the spark plugs, instantly killing the engine's power right when the pilot tried to accelerate. It was a classic case of over-engineering. The complex automatic system was the P-38's greatest weakness, and the solution, Axtell realized, was going to be simple. Axtell had an idea. It was simple. It was unauthorized. It was, to the high-ranking engineers, completely stupid. He proposed bypassing the entire complex automatic mixture system. He would disconnect the faulty automatic wire and replace it with a manual wire linkage. This simple trick would give the pilot direct control over the fuel mixture. If the engine sputtered, the pilot could just lean out the mixture with a simple lever, preventing the plugs from fouling. It was a 10-minute fix that cost pennies. It tossed out the advanced engineering in favor of basic control. The senior officers who saw the plan dismissed it instantly. They called it an idiot fix that was dangerous and against every regulation. But Shorty Axtell knew the regulations were killing the pilots. The mechanic went directly to his pilot, Dick Bong. Bong was the squadron star, the one whose life depended most on the P-38 performing flawlessly. Axtell explained his theory. The highly sophisticated automatic system was choking the engine, and the fix was simple manual control. He had to be honest. It was against regulations. It was dangerous. A senior officer standing nearby overheard the discussion. He didn't hesitate. He loudly dismissed the idea as reckless, an idiotic trick that would certainly blow the Allison engine and cost the Air Corps a $1 million plane. But Bong had lost faith in the engineers. He hadn't lost faith in the man who scraped the oil off his spark plugs every night. He looked Axtell in the eye and simply said, "Do it." Axtell performed the modification on Bong's plane, Marge. The stakes were now absolute. Bong was not just risking his life on an unauthorized repair. He was betting the future success of the P-38 on the intuition of one dedicated mechanic. Bong took off. This was the true moment of risk. He wasn't sure if the engine would fail or if Shorty's stupid manual wire trick would solve a problem that stumped hundreds of factory engineers. He climbed to 25,000 feet. The engine, as always, began to sputter. The gauges showed the deadly mixture problem starting again. He reached for the new, dedicated manual control, the lever that Shorty had rigged. He leaned out the fuel mixture. The engines instantly roared to life. They ran smooth, powerful, and clean. The faulty automatic system was bypassed. The power was back. Bong couldn't believe it. The fix worked. He landed and immediately told Shorty the great news. An unauthorized 10-minute fix had solved the P-38's fatal flaw. The success of the stupid wire trick was too profound to be ignored, even by the stubborn high command. Shorty's fix spread like wildfire. It was an unauthorized modification, technically illegal, but the pilots were desperate. Every P-38 inches, Bong's squadron, then every plane in the theater, secretly received the manual mixture linkage. The word went out. Get the Shorty fix. The men in the field proved that simple, effective field engineering was superior to complex, failed factory design. The change was instantaneous. The P-38 was finally flying as designed. It was no longer a sputtering liability. It was a powerful, high-altitude killer. The unleashed potential of the P-38 immediately changed the balance of power in the air. The American pilots could now climb with full, reliable power and maintain maximum speed. They used their signature tactic, boom and zoom, perfectly. They would dive from above the zeros with massive velocity, shred the Japanese planes with their process, concentrated nose guns, and then use their superior engine power to zoom straight back up to altitude, completely out of the Zero's effective turning range. The tables had turned. The Zero, once untouchable in a dogfight, was now terrified of the P-38. The American Widowmaker had become the feared Zero killer. This one small wire trick did more than just save a squadron. It helped forge the top American aces of the entire war. The P-38 was now a reliable platform for those with extraordinary skill. Dick Bong would go on to shoot down 40 Japanese planes, becoming America's ace of aces. Thomas Maguire would follow closely, scoring 38 kills. Both men flew the P-38 Lightning in the Pacific, and both owed their unprecedented success, in part, to the fact that their engines no longer quit when they needed them most. The simple, unauthorized adjustment by a mechanic fundamentally transformed a failing, costly machine into the dominant fighter of the Pacific theater. It was the moment field intuition defeated factory arrogance. The engineers in California finally received the reports of the astonishing success. They were initially hostile, rejecting the idea that a field mechanic had solved a problem that baffled their labs. They called the fix crude, but the evidence was undeniable. The P-38's combat performance had spiked dramatically. The simple wire trick wasn't just working, it was saving planes and winning battles. Reluctantly, they adopted the fix. They formalized the manual mixture control, calling it an emergency altitude control. They never credited Gene "Shorty" Axtell publicly, but they quietly began incorporating the principle into new models. The greatest consequence of the stupid wire trick was the end of the Zero's dominance. Before Axtell's fix, the Zero was the undisputed king of the low-altitude fight. Its high kill ratio forced American pilots to fly defensively. After the fix, the P-38 was unleashed. It could now climb and dive with dependable power, forcing the Japanese to change their entire aerial strategy. The P-38 was instrumental in the air superiority that led to the Solomon Islands campaign success. This small, simple field fix did more to turn the tide of the Pacific Air War than almost any single factory upgrade. The plane went from a failure to a primary tool for victory. The Bong and Maguire fix, as it was often called by pilots, became a symbol of a deeper truth in military engineering. The field knows best. The man who maintains the machine understands its flaws better than the man who designed it. The engineers were focused on perfection. The mechanic was focused on survival. Axtell didn't care about theory. He cared about eliminating the variable that was killing his pilots. He proved that sometimes throwing out the complex, automated solution and returning power to the skilled human operator is the only way to win. Years later, the engineering community finally acknowledged the crisis. They admitted the automatic mixture control system was overly sensitive and flawed for the Pacific environment. But they rarely, if ever, mentioned the mechanic by name. The story of the simple wire trick remained a quiet legend among P-38 veterans, a tale of underdog genius and bureaucratic stubbornness. It stands as a perfect illustration of how innovation in war often comes not from high-tech labs, but from the desperate ingenuity of the men on the front line, fighting to keep a plane flying with whatever tools they have. This small, unauthorized modification permanently cemented the P-38 Lightning's legacy. It was transformed from a costly liability into one of the most successful, unique, and powerful fighters of World War II. The reason the P-38 outmaneuvered every Zero and dominated the skies of the Pacific can be traced back to one mechanic, Shorty Axtell. He took a piece of wire, ignored the regulations, and used his experience to solve a fatal engineering flaw. He proved that a stupid wire trick was sometimes the smartest solution of all. He was the unsung hero who won the air war.